Hi, we're back in the second slideshow from chapter 3 of our data computing course. In the previous video, we looked at univariate displays, and now this video and the next one, we're going to be talking about what happens when we have more than one variable that we're interested in displaying at a time. This video will look at one categorical and one numerical variable. And our two main tools that we're going to be using for this are violin plots and box plots. So let's chat about the violin plot for a couple of minutes. We saw an example of this in our slideshow for chapter 2. We use geom_violin to do this plot. Suppose that I wanted to break apart the wage data from CPS small. Recall we excluded an outlier in the previous video, and we want to break that down by sex. And so we're going to have sex on the horizontal axis. We have two different plots, one for males, one for females, and we're going to do violin plots on wages. And so let's take a look at that. I talked about this a little bit in class. Just very briefly, like a density plot, the width of this plot at any point is dependent on the number of observations that occur in a range around that value that's in this case on the vertical axis. So we've got the female violin plot here, the male violin plot here, and we can see that there's the male values are wider for the most part in lots of places than the female plot, and so that's a signifier probably that there are more men in this data set making higher wages than there are women. So we want to be able to again read that the width of a violin, quote violin, is determined by how many points observations are in a given range on the axis over here. We can actually add the data points to a violin plot, in which case we would want to add some jitter so that if we have lots of observations at a single value, they're not just standing on top of each other. Again, the jitter allows you to better see how many data points there are in a given range of wages in this case. Width inside geom_jitter basically tells how much you can add either to the left or to the right in order to spread the values out. And we'll see what we think that 0.25 means when we get to our output. And size is giving us the size of the points. Because we have a lot of points here, we probably want to make their size relatively small. And so remember that the width is 0.25. What that seems to mean in this case is if you look at the distance between our two, quote, axes here, then 0.25 seems to be how a quarter of the way between the two of these axes. And so it looks like I'm going as far out as about a fourth of the way over, and this looks like about half that distance between F and M. And so that tells you how far apart, how much you're allowed to add or subtract from quote 0, which would be laying right on this axis, in order to get a feel for how the frequencies of the values over given ranges. And again, while we've got more men in our data set, apparently there are more values up here at higher wages than there are for women. And again, remember this data comes from 1985. And so that maybe there have been changes in the ensuing 35 years, at least to some extent. So that's violin jitter. Let's spend a little time now talking about box plots, and we'll take some time to remind ourselves of what information is contained in a box plot. But we're actually going to do the same, we're actually going to do a little bit different thing here. We're going to have our horizontal variable be the sector in which a worker performs, and then the y-axis will be their wage. And so gm underscore box plot is going to generate box plots. We're filling those in as well. And so we've got apparently 8 different possible sectors in which our employees could have identified themselves. One of them is other. So we have 7 main divisions plus a catch-all category. And we can see that we've got a variety of differences between sectors in terms of response, but we need to actually remind ourselves, what do the boxes represent? How do we determine the height of a box? And what are those dots that are here on the high side in all these cases? So just a bit of a reminder of the information that's contained in a box plot. We've got quartiles for our data. For a data set, for any given data set, the first quartile is going to be the number that essentially cuts off the lowest 25% of values. 25% of the values will be below it. The third quartile is a number for which 25% of the data values will be above it, or 75% below it. The number Q3 minus Q1 is called the interquartile range. The median of a data set is going to be the midpoint of the data set. And so we could calculate the what we call the 5-number summary for wages by sector using the RStudio command favstats. And so we'll take a look at this sort of command from time to time in this course. But favstats, we give the numerical variable broken down by the categorical variable. We tell what data set it comes from. And the 1 through 6 just lists what the sector was, and it gives us what we call the 5-number summary. The minimum value, the maximum value, and then the first, third quartiles, and the median, which could also be considered to be the second quartile. And so these 5 numbers are going to be involved in the box plot. So a couple of rules for how box plots are generated. Let's assume that there are no outliers, and we'll define what we mean by an outlier shortly. The lowest whisker, those vertical bars that extend from the boxes, will go from Q1 to the lowest value. The upper whisker will go from Q3 to the largest value. And then the box goes from the first quartile to the third quartile. And then the line in the, quote, the middle of the box, inside the box, represents the median. So let's remind ourselves, let's look at the clerical sector. The first quartile is $5.20. The third quartile is $9.50. The median is $7.50. So let's look for the clerical box plot here in our output. So clerical, it's going from about $5.20 to $9.50. Here's the first quartile. Here's the third quartile. 7.5 is right here. We can compare on this axis. And then the whiskers extend down to the minimum value and extend up to the maximum value. And we can see that that's generally what's going on in all the cases here, except for those that have outliers. So let's talk about now how we determine outliers. Generally speaking, we can compute the interquartile range, the difference between Q3 and Q1, and we can multiply that by 1.5. And anything that is more than 1.5 interquartile ranges above the third quartile or below the first quartile will be plotted separately as outliers. And then in those cases, if there's a high outlier, then the upper whisker will extend from the third quartile to the largest value that is not an outlier. And if there's an outlier on the low side, the whisker on the bottom will go from the first quartile to the smallest value that was not classified as an outlier. In a picture form, again, here's the first quartile, here's the third quartile, the median is the strip in the middle of the box, in the center, in the interior of the box. In this case, we've got a high outlier, but not a low outlier. So the lower whisker will extend to the minimum value, and the upper whisker won't necessarily extend to the third quartile plus 1.5 times the interquartile range, but it'll extend to the largest value that's less than this number, the largest observation in our data set that's less than or equal to this number. So we want to be a little bit careful in reading this graphic. So here's something else that we can do with geom_boxplot. We can facet. And so suppose that I wanted to do within each facet have male and female wages represented with box plots, and then we're faceting by sector. And because there were 8 sectors, we're going to put this into 2 rows. And so if we do that, here we've got 4 pairs of box plots on top, 4 on the bottom. We see that there are no females apparently who responded that they were in the construction industry, but we get a sense in each of the 8 categories, each of the 7 that have responses for both men and women, how wages compare within each sector. And so this is a nice result where we can do faceting in this regard. So we get some decent comparisons. Switching gears just a little bit here while we're still talking about categorical variables. Let's go back to a bar chart, and we're going to see something kind of cool that we can do with a bar chart. So we're just going to look at, we're breaking things down by sex, males and females, and then in our bar, within each bar, we're going to fill it by responses to the variable seat. So we remember that we've got front, middle, and back. And so what we're going to do is we're going to fill in our bars with seat responses. And then chord flip is going to, instead of having the bars go arranged vertically, it's going to arrange them horizontally. So let's take a look at this. And so what we see is we've got counts on the horizontal axis now rather than the vertical axis. And then we can tell by each color how many people responded for within each sex about sitting in the front, middle, and back. So take some time to study this, how we're using the aesthetic on the geom_bar to get the colors inside the bars. In our last video for this chapter, we will talk about 2 numerical variables.